zoom it right here. What we're going to start out doing is we're going to start out on the universal scale, then we're going to zoom in to galaxies, then we're going to zoom in to stars, then we're going to zoom in to planets. We could have started small and zoomed out, or we could start wide and zoom in. We're going to, because the textbook does it this way, start wide and zoom in. So we're going to be talking about the early universe and types of galaxies. I stole this from Stephen Hawking. Stephen Hawking is the wheelchair guy. He's the scientist that's in the wheelchair that speaks with a computer-assisted voice. He said, "We are just an advanced breed of monkeys on a minor star, on a minor planet of a very average star, but we can understand the universe. That makes us something very special. Right now, as far as we know, we are the only things in the universe that want to learn more about the universe. Animals don't. And maybe there is life out there. We'll talk about that. But right now we haven't found any, so right now we have to assume there isn't. We're it. We're special." The expanding universe. So, in 1929, Edwin Hubble, where have I heard that name before? What's named after Edwin Hubble that you might have heard about? Okay, the Hubble telescope is named after him. He measured the distance from Earth to, I think what you're filling in is several distant galaxies, right? Or several distant galaxies, that's what goes in the notes. Fill in the blanks. And here's what he noticed. He noticed that they were moving away from Earth and from each other. This was a shock. No one had considered that. Now you may be saying, how the heck did he figure out that they were moving away from each other? We're going to talk about that, Rihanna. But he did notice, holy smokes, stuff is moving away from each other. The universe is expanding. If you can measure how fast something is going and see where it is, you can figure out where it used to be. For example, if you've ever seen a jet passing high overhead, well, if I see it going this way, I know a few minutes ago it was back there before I heard it. Okay. Keep the seating plan going around wherever you think it needs to go. So, when they looked at where the galaxies used to be, they all used to be in the same place at the same time. And this led to the theory of how the universe came into existence. What do we call that theory? There's a TV show named after it. The Big Bang Theory. By the way, it was given that name sarcastically by someone who didn't believe in the Big Bang Theory, but it's caught on. And it's kind of a misnomer. It's not like there was a big boom. It's much more complicated than that. But this is our current understanding of the universe. So, we notice that galaxies are getting further from each other. If we go backwards in time, they used to be closer. In fact, we believe all the matter in the universe was at one point condensed into a very, very tiny singularity, and then the universe began to expand. Okay? Thank you, sir. How the heck did he figure out that galaxies were moving apart? It's not like you can time them, they're so far away. It's not like you can use a radar gun, they're so far away. How did he figure this out? We need to talk about something called, and this is going to be important, redshift. So, visible light is a very small part of you did this in Science 8, electromagnetic spectrum. I'll show you a picture in just a second. I'm going to come back to this screen, but here is the picture of the electromagnetic spectrum right here. Okay? Visible light is this little section right here. It goes to the left as we get waves that are longer. Infrared, microwaves. Microwaves, although they're called micro, they're actually pretty big. Radio waves. As you go to the right, you get ultraviolet radiation, or UV, X-rays, gamma rays. Also, for what it's worth, Lena, as you go to the right, these do damage to you when they hit you. As you go to the left, these don't possess enough energy to do damage to you. In fact, most of these, some of these will bounce off you, some of these will go through you. These ones have enough energy that if they hit your atoms in your body, they can knock off an electron, which suddenly means an atom goes from being neutral to wanting to have a charge. And if we're talking about your DNA, that's a bad thing, because now your DNA wants to combine with other stuff. So this is why we try and minimize how many X-rays you have. Gamma ray, the Incredible Hulk was exposed to gamma rays in the comic books. Now that science is incorrect, but exposure to gamma rays, when they talk about radiation poisoning, usually they're talking about radiation from gamma rays. That's what kills you. We barely see anything. By the way, your cell phones give off microwaves, same as the microwave ovens. If you could see in the microwave spectrum, your cell phones would look like flashlights to you, because they are giving off a huge amount of radiation. It's just your eyes can't see at that particular spectrum. But if you could, or if aliens came here and if they could see in the microwave bandwidth, it would be like all of us were holding mini flashlights to them. Kind of cool. So, back to here. Red light has a longer wavelength than blue light. Red light has a much longer longer wavelength than blue light. So if we're talking about redshift, what does that mean? We're talking about red light. Turns out, as space expands, the light sent towards us by distant galaxies gets stretched. And that makes that light look more red. Nicole, the fancy word we have for that is redshifted. We say that the galaxies are redshifted. And this is how Hubble realized the galaxies were expanding. As he was looking at all these galaxies, he noticed that the light that he was seeing in his telescope was all shifted very, very slightly to the red. And that only happens when objects expand or are moving away from us. So it turns out, if you want to visualize, as an object moves away from us, the light gets red shifted. If an object is moving towards us, the light gets blue shifted. And this is how we can measure the relative speeds of stars. We actually measure the shift in their frequency of light. We can do that, and we'll talk about how that works. Okay, so red shifted is when you're moving away. Blue shifted is when you're moving towards. And there is our visible light spectrum. Put your pencils down. That makes sense? Okay. Something as simple that you hear all the time, cars going past you and the pitch changing. It's the same physics, Nicole. It's the same math that lets us figure out, with instead of sound, with light, that the stars are traveling away from us because their pitch, their frequency is getting smaller. There are a few stars moving towards us, but the vast majority are moving away. Pick your pencils up. So here's an example. I gave you a little picture. This is called a spectroscope, there is a way that you can look at stars and figure out what elements are in the stars, and it has to do with these black lines. So if you know the chemical composition of a star, and we know the chemical composition of most stars, Nathan, if you notice this, you would say, oh, It's been shifted towards the blue. It's moving towards us. So we have not moving. Moving, it shouldn't say from us. It should say moving towards us. So can you, where it says the word from, cross out the word from. Apparently I was cutting and pasting and didn't do a good job. See the little picture there? It says moving blank from us, moving toward us. The spectral lines have the same pattern, but they're just shifted to the blue end. Not many stars, not many galaxies have that. Lexi, the vast majority are moving away from us. Same pattern, but shifted towards the red end. The fancy word for this, redshift. I guess that's 2 words. We say that the universe, most stars in the universe are redshifted. By the way, nerd moment, what's actually expanding is the space-time between them. The universe is expanding in that the space-time continuum is getting bigger. But that's a little Einsteinian physics for you. Put your pencils down. So we've been talking about galaxies. Give you some quotes again here. Sometimes I think we're alone in the universe, and sometimes I think we're not. In either case, the idea is quite staggering. Arthur C. Clarke. Arthur C. Clarke died just 2 years ago, I believe. Science fiction writer who wrote many good science fiction books. Also, though, he was the inventor of the satellite. He wrote a paper back in the 1940s saying, I think you could get stuff to stay up there and bounce signals off of it. Galaxies. What is a galaxy? It's a group of stars and gas and dust held together by gravity. We are part of the Milky Way galaxy, which consists of, you know what, your notes say 100 billion stars. It has changed. Now we think there's closer to 300 billion. So you can cross out the little 100 in your notes, write this down, and make it a 300 billion. That may change as we're getting better and better telescopes up there. So what's a galaxy? It's technically a group of stars, but Nicole, it could also be dust and asteroids and and other stuff. What's our galaxy? The Milky Way. Why is it called that? Because if you're ever in the middle of nowhere, away from any lights at night, you'll see a big milky smear go down the middle of our sky, and those are the stars in our galaxy. Don't write this. Oh, I have this in there. If a star were a size of the grain of sand, there would be 100 billion grains of sand in a dump truck load. The universe is thought to hold 125 billion galaxies. I ran some quick math. Imagine dump trucks full of sand racing past you at the rate of 1 every second for 1,000 years. That's about how many stars we think there currently are in the universe. And again, Kiana, I can't wrap my brain around that. The universe is big. It's huge. Bigger than I can imagine. I wrote here, the numbers are bigger than I can imagine. I got a math degree. I can imagine some pretty big numbers. Types of galaxies. So, the first type is what we call a spiral galaxy. What shape would a spiral galaxy be? In the shape of a spiral. Got to be fussy, not quite it's going to be a spiral, okay? So here's what it has. It has arms that spiral out from the center. The Milky Way, we are a spiral galaxy. It can have many arms or 2. One with 2 is called a barred spiral galaxy. So it would look like this and have a big clump of stars in the middle. But most of them kind of look like that. If you see it from the side, it has a central bulge. I stole some pictures from the internet. Some of these are Hubble images. So if you see it from the top, it looks kind of spirally, but if you see it from the side, there's a central bulge. Write that down. The central bulge is the older stars. The arms are gas and dust and younger stars. So we are a lovely spiral galaxy. And if you have to be away from any city lights, but if you're ever out camping in the middle of nowhere and you look up at like 2 in the morning on a clear, crisp night, you will see a big smear running down the middle. You're staring at that central bulge where all the older stars are.
How big are those pictures? Like how big?
These ones are from the Hubble and telescopes. This is not the Milky Way. I'm going to show you a simulation of the Milky Way in a second. These are other spiral galaxies. And you can actually, I got a good pair of astronomy binoculars. I can make out a smear when it's a galaxy, not the full spiral, but oh yeah, you can totally see this with like the Hubble or better telescopes. You can see this kind of imagery. Okay? But yeah, you're asking, how did they get the picture of ours? Because the galaxy is so big, it's not like we can get a photo out there. We have simulations. In fact, there's a famous shirt you can buy. Here's the shirt you can buy. That's a simulation of the Milky Way, or that's some other spiral galaxy that they're saying looks like the Milky Way. But we do know from our observations the Milky Way looks like this, spirally. And we do know that we are on the edge of the Milky Way, because we're part of the younger stars, not the older stars. But yeah, you can get this shirt. You are here. I need to find one and buy one. I know. It's one of the few nerd shirts I don't own. Put your pencil down. Pick your pencils up again. Quote for you. We live on a hunk of rock and metal that circles a humdrum star that is one of 400 billion other stars that make up the Milky Way galaxy, which is one of billions of other galaxies, which make up a universe which may be one of a very large number, perhaps an infinite number of other universes. That is a perspective on human life and our culture that is well worth pondering. The next time you look up at the stars, think some deep thoughts. And that quote's by Carl Sagan. Second type of galaxies. First type is spiral. Second type are what are called elliptical. And this is why when somebody said circular, actually elliptical looks sort of circular, which is different from a spiral. I gotta be fussy. They can range from a perfect sphere almost to the shape of like an egg or a cigar. Over half of all the galaxies are elliptical. So this is the most common type of galaxy. You know what? I didn't include this in your notes, or did I? Nope. You might want to write this down somewhere under, you have some space to the right. The largest and oldest galaxies are elliptical. Oh, it does say that? Oh, there it is. The largest, oh, there you go. I'm reading the same thing twice. The largest and oldest are elliptical. We think they form, oh, here's some pictures. There's an elliptical galaxy. I don't know which one that is. We think they form when one galaxy eats or collides with another galaxy, pulls it into itself. So here's a picture of two spiral galaxies colliding. They each have gravity, and their gravity is pulling them towards each other. We're going to collide with another galaxy. We are on a collision course with our nearest galaxy neighbor, Andromeda. And somebody's done a simulation video of what that'll look like. So put your pencils down. Pick your pencils up. The third type, by the way, there are more types of galaxies. Kiana, these are the three main types. Spiral, elliptical, looks circular or like an ellipse. Irregular is kind of a group of different that don't fit into spiral or elliptical. So irregular, these are a mix of older and newer stars. They're really anything that doesn't fit the other two groups. So here's some pictures of irregular galaxies. You'll notice, does this look like a spiral? No. Does this look like a circle or a sphere? No, it's irregular. Okay. Some of the irregular ones, though, look very spectacular. This one here is very, very pretty looking. In fact, it turns out, put your pencils down, the largest galaxy in the universe. Last thing I want to talk about are star clusters. So galaxies contain clusters of stars. There are two main types of star clusters. There are globular or globular, and these are up to about 1 million or so stars, and they're usually round, shaped kind of like a globe. That's why they're called globular. They're held together by their mutual gravitational attraction. And then we have what are called, here's a picture of a globular star cluster. It is shaped kind of like a globe, roundy shape. Then there are open star clusters. These are a few hundred to a few tens of thousands of stars. Not so many. And usually, Hudson, these are irregular. So as a picture, the Pleiades, which is a famous star cluster, they look very pretty, but they're not regularly shaped. You don't see any, that looks like, it looks like a bunch of scattered dots. I'm going to give you the homework to work on, and then I'll play a couple of videos for you.